Alright, fellas, let's get rolling. With Newton's laws of motion, this falls under the category of forces of motion, which arguably does carry the most marks in the exam, so pay extra attention here. What I do suggest is they're very short videos, so watch them, pause them quite often, and just write down whatever I've written down there because it helps quite a bit. Okay, so Newton's laws of motion. You have to memorize them, you have to apply them. What I mean by this is Newton's first law states very bluntly that an object will either remain at rest, aka the speed is zero, or it'll move at constant speed provided resultant force is zero. So what we mean here is, and I can give you a very good example, is you have a car, you have a force this way of 2,000 newtons, you have a force this way of 2,000 newtons. Now logically, if someone's pulling this way with that much, someone's pulling this way with that much, they cancel each other out because they're equal and opposite forces. Opposite because they're moving in the opposite direction. So this and this cancel. So 2,000 minus 2,000 is 0. That means your resultant force, aka the sum of all forces, is 0. So that means the car will either be stationary or will move at constant speed. Now you're probably wondering, how can it do both, or how can it do one or the other? If a car was already in motion to begin with, and then the forces happen to balance out, then it will just remain in motion, so aka it will still move, but it'll move at a constant speed. If you just have a table, and you just have a random book on the table, for instance, and let's say the downward force is 200 newtons due to weight, the upward force is 200 newtons, they cancel each other out, but obviously the book wasn't moving, it was just resting on the desk. Therefore, it'll remain motionless, aka stationary. Yeah? So usually for cars, almost always in the exam, you have to say that if it was already moving, then it moves at constant speed provided the overall sum of forces or the resultant force is 0. If it's a book or something which is stationary, then it just remains stationary. Yeah. Let's look at this example very quick. You have 4,000 this way and 2,000 this way. We take them away from each other, and what we find out is that if you do this one, take away this one, we get 2,000. And which way is it going? It's going this way because the greater force was moving that way. Yeah. If I give you the exact opposite now, but I say 4,000 is this way and 2,000 newtons is here, take them two away from each other, you have 2,000, but it's moving this way since this is a larger force. Yeah. So that should make sense. Once again, here another example. 12,000 minus 4,000 gives you 8,000. The resultant force is just the sum of forces, aka you just subtract them because they're in opposite directions. Here, the objects will remain either at rest or constant speed. Alright, so I hope that does make sense, guys. Newton's second law is quite simple. It's just fam, so you got resultant force is equal to acceleration times mass. Yeah, you have to memorize this formula, and you use it a heck of a lot. Now, very simple question, let me show you. They give you a car and they tell you the mass is 100 kg, right? So they've given us this number here. And they give you one force this way, one force this way, and they tell you work out the acceleration. Now look here, I know it's a bit weird. We want acceleration, so first off we need to rearrange this. For those of y'all who love triangles, here you go. So resultant force is at the top, and you have these two at the bottom. So if we're looking for acceleration, you put your finger over it. So it'll be F divided by M, right? So we have acceleration is force over resultant force over mass. We got the mass already in the question, which is here. They literally spoon feed you that. All we need is resultant force. Resultant force is not just this force or just that force. Remember from before, you have to take the two forces away since they're going in opposite directions. So 2,000 minus 1,000 gives you 1,000 for your resultant force. When you divide these two, you get 10 meters per second squared, and that is your acceleration. Very common question. Always give you objects, two forces opposites, give you the mass. Just find the resultant force by subtracting the forces, then divide it by the mass of the car, whatever object there is. Yeah. So that's Newton's second law. Newton's third law, probably the easiest one. For every action, there's an equal opposite reaction. So right now, if I'm applying a force downwards with my finger, let's say 100 newtons, right? This table is also going to apply an upwards force of 100 newtons, which is why my finger is not moving. So equal and opposite forces. Similarly here, the guy sitting on the chair, or at least it looks like he's sitting on the chair, is applying a downwards force due to his weight or her weight, and the chair will also apply an upwards force to counter it, which is exactly equal and opposite. Therefore, the person remains stationary. Yeah, so this is just, I guess you just need to memorize it. They do ask you to apply Newton's third law in certain scenarios. There's no mathematics involved. For example, here, you have a truck pulling with a rope a car. What the hell is not even attached? So you have a truck pulling a car. Now, they might say the forward force on the rope this way is 3,000 newtons. So it's basically the force that the truck is pulling the car by. We have to understand that there's an equal but opposite force tugging this way of also 3,000 newtons on the rope from this side, yeah? So this side of the rope is pulling 3,000 and this side's 3,000 as well. And this is an example of Newton's third law. So these are just three of Newton's laws. I do hope it makes sense.